Hello, everyone. Welcome back to another episode of Math Unlocked with Mrs. Rhodes-Grierson. Now, today we're going to be taking a problem-solving approach to fractions multiplication. So let's look at the problem and let's see how is it that we're going to be using all of our fraction skills to answer this question, and we're going to dive into fractions multiplication, right? So it says a recipe requires 3/4 cups of sugar to make a 2 pounds cake. So we're making a cake. The cake is going to be a 2 pound cake, and we require 3/4 cups of sugar. So if you're a baker, like myself, you want to ensure that your proportions are accurate so that the result is excellent. You don't want it to be too fresh. You don't want it to be too sweet. You want it to be just right. Now, today we're deciding that we want to bake a cake, but we don't want a 2 pound cake. A 2 pound cake is too big for my small family. I want a 1 pound cake. So let's look at this. It says how much sugar is needed for a 1 pound cake. Let's add that word, cake. So we're creating a 1 pound cake. Let's, first of all, when we do reasoning and problem solving, we're going to look at what am I asked to do? What do I want? I want to know how much sugar. How much sugar for a 1 pound cake. That's what I want. I'm going to look at what do I know. When we try to solve problems, we try to connect our unknown to our known. We know that 3/4 cups of sugar will make a 2 pounds cake. Let's make the connection now. The connection. Our connection is that we know that 3/4 cups will give us 2 pounds. Now we want to know how much cups will give us a 1 pound. The connection between these two things is that cups per pound. Here I had 2 pounds and now I have 1. If I should compare them, I know that the amount that I require to make is half of the amount that I was originally making, half of it. That part is very important, I'm comparing the fact that I need to make a 1 pound to the fact that what I was making before was a 2 pound. So the requirement now is that I need to have half of the amount that I was using before. How does that affect the sugar? Over here, we were originally using 3/4 cups of sugar. Now, if I'm going to be reducing the size of the cake by half, it now means that I need half of what I was using before. Let's write that down. I need half of the amount of sugar, and the amount of sugar was 3/4 cups. So now I need half of that amount. Now, one thing you must know is that in a mathematical statement, if you're asked a fraction of a quantity, you need to know what that means. So let us see if we can visualize that. We're just going to draw something here. Let's look at what if I had a whole and I divide this whole into 4 equal pieces, which now means that each one of these represent a quarter. So this is 1/4, 1/4, 1/4, 1/4. Each quarter adds up to become 4 quarters, which is 1 whole. Now, what did I have? I had 3 quarters. I had this one. So I had 1, 2, 3. I had 3 of those. The question is asked, what's half of 3/4? Half of it literally means that I'm going in, and each one of these I'm going to cut them into 2 equal pieces to get half. So I want this into halves, this into halves, that into halves, and even the one that I'm not going to be using, I'm going to divide it into halves as well, because with fractions, it requires that all of the whole is divided into equal parts. So I am changing the original fraction that was currently quarters, I'm splitting those quarters into 2 equal pieces because I'm trying to divide now what I originally had into halves. Be dividing it into halves and divide it into 2 equal pieces. So each quarter is now going to be cut into 2 equal pieces, which now means that the piece that I'm looking at, now this little piece here, so is going to be one piece out of 1, 2, 3, 4, 5, 6, 7, 8. So the whole is now divided into 8 equal parts, such that this quarter is now going to be 2 eighths, because 1 8 plus 1 8 would represent a quarter here. What am I doing? I was required to decide what is half of 3/4. What's half of that? We had 3/4. I now split each one of them into 2 equal pieces. I'm going to be taking half from each one. One of this, one of this, one of this. So I would have taken 3/8 out of that 3/4 that I had, because originally it was 3/4. 1/4, 1/4, 1/4. I split them into 2, so each one is now 1/8. Taking half of that, taking half of my 3/4, I take 1, 2, 3 of them, because I have 1, 2, 3, 4, 5, 6 of them. I took 3. 1, 2, 3. That's going to be half of the 3/4 that I had. Remember, we didn't have this piece. So we're focusing on the 3/4, which is around here. We're focusing on this piece here. This is my 3/4. Now my 3/4, I divided into, each one was divided into 2 equal parts. Now means that I have 1, 2, 3, 4, 5, 6. How much did I take? I'm taking half of that, so I'm taking 3. 3 out of what? No, it's not 3 out of 4. It's not 3/4 anymore, because I divided up into 2, which now means the whole is out of 8 equal parts. So half of 3/4 would give me 3/8. This is a pictorial representation of what is happening. Now the procedure part of it. What would I show you if I was not drawing a diagram to make it connect to procedure of how to multiply 2 fractions? I'm going to get the same 3/8, but let's see how. All right, so let's go. I ask, what is half of 3/4? Half of 3/4. That's the of implies to multiply. So that's half times 3/4. The of implies to multiply. Now, when multiplying 2 fractions, different from addition and subtraction now, when multiplying 2 fractions, based on what that means, it means that the numerator multiplies my numerator. Now I have 3 being represented as my numerator. Top times top, bottom times bottom. 2 times 4 will give me 8. Is that exactly what I got when I decided to cut up my whole into now further dividing my quarters into halves to show that half of 3/4 represents, now procedurally, if I'm going to multiply 2 fractions, all I need to do is to multiply my numerator with my numerator and my denominator with my denominator. So half of 3/4 is 3/8. All right, let's continue. Now we don't have a word context. We're just presented with the statement, what is 2/3 of 3/5? Notice when I'm stating the fraction, I read the fraction as what the fraction means. 2/3 of 3/5, which means this fraction was divided into 3 equal pieces and this one was into 5 equal pieces. The number of when implies a process of multiplication. 2/3 of 3/5 means 2/3 times 3/5. We go ahead and multiply numerator with numerator, denominator with denominator. So we say 2 times 3, that's 6. 3 times 5, that's 15. One important thing to note, students, is that when you get a fraction, this is proper. The numerator is smaller than the denominator. It is proper. However, The number 6 and 15 are both divisible by 3, which means that this fraction can be reduced to a simpler fraction. I will use 3 to divide both numerator and denominator. So we say 3 into 6 goes 2 times, and 3 into 15 goes 5 times. So an equivalent fraction to 6/15 is 2/5. So the solution of 2/3 of 3/5 is 2/5. So we're going to explore it all. What if you're given a statement at 2/3 times 5? Now 5 is a whole number. We just learned that when we're multiplying fractions, we use numerator by numerator and denominator by denominator. But there's no denominator here. Well, you must take note that all whole numbers can be written as fractions upon 1, which means that 5, the whole number 5 is equivalent to 5 over 1, which is to say that 5 divided by 1 is still 5. We have each whole requiring 1 piece. I have 5 of them, so I have 5 wholes. Always remember to write your whole numbers upon 1, so make them fractions before you go ahead and multiply, because you will require to multiply your numerator by your numerator and your denominator by your denominator. If you don't have any denominator, what are you going to use to multiply? You will get something wrong if you do not ensure that you put your denominator in. Right? Now we're going to go ahead and multiply our top with our top, numerator with numerator. That gives me 10. Denominator with denominator, and that gives me 3. I'm observing my fractions and I notice this is improper. The one before was proper. This one is improper. It's improper because the top is bigger than the bottom, which means that I can get a few wholes out of this 10 because each whole requires 3 pieces. So if each whole requires 3 equal pieces and I have 10 of them, it means I could get 3 wholes. I can get 3 groups of 10. 3 groups of 3 out of this 10 with a remainder of 1, and that would be 1/3 because each piece represents a third. So I can convert my improper fractions to mixed numbers. All right, so we're exploring it all. Would have looked at a proper fraction times a proper fraction times a whole number. Now we're looking at a mixed number times a mixed number. What am I required to do? Now, one of the videos that you would have done before allows us to convert from mixed numbers to improper fractions. When you're going to multiply 2 fractions, always remember to convert them first. So we're going to convert. We multiply and we add, and this would have been taken care of in a previous video. We multiply and we add to convert. So if we have 2 1/4, we really want to know how many quarters is this in all. If we have 2 wholes, 2 times 4 is 8 plus 1, that's 9 quarters. That's 9 quarters times 2 times 1 is 2 plus 1, that's 3 halves. We now have multiplication of a fraction by a fraction, so we go with our numerator times numerator, denominator times denominator. 3 times 9 times 3 is 27, and 4 times 2, that's 8. I realize I have an improper fraction, so I could say, how many groups of 8 can I get out of 27? I can get 3. 3 eighths is 24. That means I'm left with 3 pieces of 8. So that's 3 eighths. So when you have mixed numbers to multiply, always remember to convert. Once you would have converted, you multiply numerator with numerator, denominator with denominator. If improper, you can convert to mixed. All right, students, I hope that this video, though quick, would have given you all you need to know about fractions multiplication. Do remember to subscribe to the channel, like the videos, share with your friends. Come right back for many more videos to come. See you soon.